We have been writing ROS2 nodes for a few episodes now, and each time we run them manually from the command line. This is fine for testing your nodes and debugging, but it becomes a bit of a pain if you want your robot to start functioning with all nodes running from a single command line call. That's where launch files come in. ROS2 has a straightforward process of creating scripts that launch multiple nodes with given parameters. In the previous episode, we explored node parameters, allowing us to run them with different configurations. ROS2 allows for creating launch files with XML, Python, and YAML. We'll focus on just XML and Python, as those seem to be the most popular. These allow us to start running multiple nodes and specify parameters in the launch configuration. Let's get started. You can find the official documentation for launch files if you go to the documentation for your distribution, go to tutorials, intermediate, launch, and creating a launch file. Feel free to follow this, but we're going to break it down in this video, and I'll show you some extra steps that aren't necessarily covered here. So let's go to our Docker container. We will open up VS Code. In there, we're going to go into our workspace. Let's go to source. Let's go to our C++ package. And we're going to create a new folder called launch. And we're going to create a file in launch called pub/sub example launch.xml. Note that I'm creating my launch file in an existing package that has source code. This is fine for smaller packages. So I'm going to show this to you as an example. But in most cases, you will want to create a separate package for just your launch and bringup code for things like parameter configurations, your launch scripts, and so on. Let's start with this, and then I will show you later how to do it in a separate package. XML was the only way to create launch files in ROS1. You can still use it in ROS2, and it's great for very simple launch files. However, ROS recommends using Python as the new way to create launch files, and I'll show you that next. So this will give you an example of how to do it in XML, and then we will create it again in Python. You might come across instances where you will see .launch.xml. That was the ROS1 recommended naming scheme for launch files. The ROS2 way is _launch and then .xml. We will write launch as our first tag. A tag in XML, much like HTML, is surrounded by this less than and then greater than symbols. Under this launch tag, we will create some child elements, also known as subtags. Here we will create a node tag, and then we will give it some attributes in that tag. So pkg is the package, that's the parameter. We will give it my CPP package, and we will give it the executable name, in this case, publisher with params, the one we wrote in the last episode. You can then close the tag immediately with this /greater than symbol. This is the same thing as doing this, where you open the tag and then you immediately close it with node like that. So this is just a shorthand to do that. We will create another subtag or child element here, also called node. We will give it a different package, this time my py package, and then we will set the attribute executable to minimal subscriber. So this will launch both nodes with one command line. Since we've defined all of our child nodes, we will close out that launch tag. Let's save this with Control S. We want to go into package.xml. We need to include a dependency here, and that will be the ROS2 launch package that ROS now needs to use in order to run this launch script, or read our launch configuration file and then execute the nodes that are specified in there. This dependency is for executables, so we'll say exec depend as our tag, and then in there, ROS2 launch is the name of that ROS2 package. Let's save that. Then we need to go to cmakelists.txt. After we've installed our binaries, which are our executables, we need to install our launch files. We'll do that using the same install function. We will give it the directory launch. This is where to look for our launch file, which we created earlier that houses our pub/sub example launch.xml. Then we will tell it where to install, and this is given by the destination keyword. And this needs to go into share/project name. And I will make this look like the others that we have done here, so it lines up with the syntax. Let's save that. Let's go to view, terminal. We'll say callcon build, -- packages select, and then my CPP package. With any luck, this will build and should now build our launch files. Looks like everything built appropriately. Let's go to our run desktop. We will bring up a terminal here. We need to go into config workspace, and we need to source our install setup.bash so that our environment knows where to find our executables and launch files. Then we're going to call ROS2 launch instead of ROS2 run. This is where we specify a launch file, and we need to tell it which package to find that launch file in. We will use myCPP package. If you hit tab twice, you should see all of the available launch options and the flags that you can use. In there, you should see your launch scripts, or in this case, just the single script that we made, the pub sub example. So I will type that out, or type pub and press tab to autofill. Press enter, and you will see that this launches two nodes. One does the publishing and one does the receiving. So you should see publishing hello and received message hello. So this is both nodes running in their own separate runtime environments. Both of them were fired up using this simple script. If we open up a second terminal, you can type ROS2 topic list, and you can see, sure enough, we are broadcasting that topic. Let's press Control-C to end those nodes and go back to our code. Let's go into our pub sub example launch, and let's modify this to work with parameters. So I'm going to put these attributes on separate lines so that we don't go over that 80 character limit here. And I'm not going to close this tag yet. And as the first sub tag under there, I'm going to say param for parameter. I'm going to give it to the attributes name equals message. So that's the name of the parameter, and then the value. Here we're going to say greetings. I'm going to immediately close that tag, and that becomes our first parameter. That's a sub tag in the publisher with params node. I'll do the same thing with the timer period, and let's set it to 0.5. Notice that I have to set it as a string here, because that's what XML is expecting. That gets automatically translated to the type expected by the node when we declare those parameters. So this should be a float, or double if it's C++, and that should automatically be translated to the correct type. We will then close out our node here. I want to talk about namespaces. And when you start having dozens of nodes, and you might have multiple publisher nodes or multiple subscriber nodes, especially as you get to topics that have the same name and you want to keep them separate among your different groups, you can use something called namespaces. This is just like namespaces in something like C++. If you remember, we have my topic that started with the slash, and that is the root of that topic name. When we introduce a namespace, that then extends to the root and then my namespace slash topic. So we can group our topics and our node names together under these namespaces. So let's see how that works. I'm going to create a new attribute here, and I'm going to call it talkie. So now you will have talkie slash my topic as the full name for that topic. Then we will modify the node that launches the minimal subscriber. Note that we need to give it the same namespace. In this case, we'll set it to talkie that matches the node earlier. If we don't, the node will not subscribe to the correct topic. Let's go ahead and add another node, and we will just copy down the same MyPy package minimal subscriber we did. So now we have two subscribers that are subscribing to my topic and listening for things published by the publisher with params node. You'll notice that we have 4 nodes here. One of them is our publisher that's in the namespace talkie. The next is a node that is a minimal subscriber. We're running that not in a namespace, and you will see why in a moment. I'm going to go ahead and divide out these attributes so you can see this more clearly. So it lines up with these other nodes. And then we're going to put these 2 subscribers in the same namespace with this publisher. So with that, let's save this. We will call con build, packages select myCPP package. Any luck, that will build. Now we're going to go over here. We're going to call the same ROS2 launch myCPP package pub sub example launch because we modified that file. You should see the 4 nodes fire up. You should see publisher starting to publish with greetings, but then only 2 of the nodes will be receiving that message. So we have talker.minimal subscriber. Notice they have the same name here. ROS assigns this number automatically to the various nodes. So we have 1 is our publisher, 2 is the subscriber that's not in this namespace, then 3 and 4 are the subscribers in that namespace. Over in the other terminal, let's do ROS2 topic list. You'll notice that my topic shows up here because we have that subscriber that did not join that namespace. So that topic exists, and that subscriber is looking for data on that topic. But we also have this talkie my topic, which is that namespace, and that's the namespace where these messages are getting published and received. Now let's call ROS2 topic info talkie my topic. Here you can see information about that topic, even though it's within this namespace. I'm going to go ahead and bring up a third terminal. We will use this to drive our graphical applications. I'll call RQT graph. Let's zoom in here. You can see that we have our talkie namespace, so the nodes operate within here. We have the publisher with params in that namespace, so you can see that there. That is publishing to talkie minimal subscriber over this my topic channel. The minimal subscriber that's not part of talkie is listed here. And you'll notice we only have one of these nodes listed, even though we very clearly have two of them running. That's because the subscriber nodes have the same default name. So if we go back to our code, if we don't name our nodes here, ROS2 will use the string given to the constructor of the node superclass in our code as the name for that node. It just so happens that we gave the node and the executable the same name. So when you start running multiple instances of the same node, you need to give them unique names if you care to debug them. You'll notice that they run just fine, but debugging them might be a little more difficult. So it can help to give them separate names. All we need to do is set the attribute name equals and give it a unique name. And that will provide an alias to that node. So we'll just say name equals publisher for the publisher with params. We will say subscriber1 for the name for our first subscriber that's not part of that namespace. We'll call the next one subscriber2, and we'll say the third one is, of course, subscriber3. Let's save that. We will build. Let's go over here. Let's shut down the nodes that are currently running with Control-C. I'm going to press up to run them again, so this should be updated. And here are the alias names that we provided. So we have talkie.publisher instead of publisher with params. We have subscriber2 and subscriber3. Subscriber1 did launch. It's just not receiving messages in this namespace. Let's go over to our second terminal. We can say ROS2 node list, and you can see our names here, talkie, publisher, subscriber2, subscriber3, and subscriber1 that's not part of that namespace. If we go to RQT graph, we can refresh it, and this looks much better. Subscriber1 is the name we gave. That node is outside of the talkie namespace. We have our publisher. We have it publishing on the My Topic channel, still in that talkie namespace, going to subscriber2 and subscriber3. So this looks much better and a lot easier to debug. Let's shut down RQT graph, and we will press Control-C to stop our nodes. Now, let's recreate this in a separate package and go over how you would do this in Python, which is kind of the newer ROS2 way to do things. Let's go back to our code. We will close this down. I'm going to collapse everything in my source directory so that you can see this a little more easily. We're going to use Python to create a launch script. It's going to be more verbose, but it does work better if you want full logic in your launch. You have access to everything you do in Python. You can read from files, add delays, and so forth. As I mentioned, ROS recommends using a separate package for your launch and bring up scripts. This is better for complex projects, so you can have your multiple packages with code in your workspace. You can bring in third-party stuff, and you can have a launch script package that exists separately to kind of oversee all of that. In our terminal, let's go into our source directory. We're going to call ROS2 package create like we've done for all the other packages. We'll say -- build type. You can use either ament Python or ament CMake. Both of these will work for launch packages. Python is generally a little simpler, so we'll stick with that. And it also seems to make sense as we are creating our launch script using Python. Then let's give our package a name. You will often see things like launch package or bringup. Those are pretty common names for launch packages. Only thing we're going to put in here is our launch scripts, so we're not going to have any code. Let's get out of this source directory in our terminal, and we will close down our terminal for now. Let's refresh our files, and here is my bringup. We can remove this Python package folder here, since we're not writing any source code. So we will delete that. Resource has this blank my bringup file. This should match the ROS package name. This blank file is used by ROS to verify that this package exists. You can usually get it to work without it, but it's not recommended. ROS generally likes this file to be here. You might run into errors if you get rid of it, so we need to leave resource. The test directory is used for things like unit testing or linting. If you want to syntax check your Python script, this is a good thing to leave in here if you want to set that up. Let's create a new folder. I'm going to create a launch directory. And just like we did with the XML file, I'm going to say pub sub example launch and then .py for Python this time. In the ROS launch package, there are a number of modules, objects, and functions you can use. We're going to use LaunchDescription, so we'll import that. There is a separate launch ROS package, and we want to go into the actions module, and we'll import node so that Python knows how to work with these particular objects so we can launch nodes. We need to define a very specific function to create our launch script. The naming here is super important. So define, generate launch description in snake case. The ROS2 launch system will look for a function with this exact name. I'll put a doc string here just to say we're going to launch multiple nodes. You probably want to fill that out with something a little more descriptive. To get this to work, we're going to create a launch description object, and then we're going to fill that out and return that object. The ROS2 system knows what to do with that once we've put everything together. Because this is Python, we can do things programmatically, like dynamically construct lists or arrays, and then use that to fill out the launch description. So I will create an empty array here called nodes. Then we will append our first node to that list. So this nodes array is just going to contain a collection of node objects. So we're going to create a node object, and we're going to fill out the package and executable just like we did in XML. The first is the package argument, which we will set to myCpp package. Then we will define the executable parameter, which will be publisher with params. That's our node that we want to fire up. Then we have namespace. If we're doing what we did earlier, this should be called talkie. We have our alias or name for the node. We'll call it publisher. Then we will define any parameters we want to pass in. In this case, they should be an array and then a dictionary. In that array, we will say message for our first parameter. We will set that to greetings as a string. And then timer period is set to 0.5. So we've appended our first node object to that nodes list. We will then define our first subscriber node. That should come from my py package. We will say it's minimal subscriber and give it the name subscriber_1. Then we will append the next node, which is subscriber2. It should have the same information, except we are going to put it in the namespace of talkie and give it the name subscriber_2. Finally, we will define subscriber number 3, and I'm just going to copy and paste and change the naming there. So now we have all 4 nodes defined, and they are part of this nodes list that we put together. And a nice programmatic way to add each of those nodes to the launch description, we will loop through each node in that nodes list, and we will call this LD for launch description .add action. That's a function in that launch description, and we pass in each individual node. So we've constructed our list of nodes. We then individually added them to the launch description, and all we have to do after that is return that launch description object. We are done. Let's save this. As we did with the XML version, we need to go into package.xml, and we need to say that this package depends on the ROS2 launch system in order to execute all of our nodes, or execute nodes within that launch context. Let's save that. Let's go into setup.py. We don't need to add individual executables here because that's for things like source code and nodes, but in data files, we do need to add something. Let's add another entry here. And here is how we tell setup tools where to install that launch script, and ROS will be able to find it in this particular location. So we will say that in share, in the installation folder, there will be the package name, so it should be my bringup. And then in launch, it should find this pub sub example launch.py, that script we just wrote. Let's save that. Let's go to view, terminal, and we need to say callcon build, packages select, my bringup, and that should install this install script for us. That should work. Let's go over to our run desktop. We need to source install setup.bash so that it knows about this new launch configuration. And we will say ROS2 launch, my bringup, and then pub sub example launch. That should fire up all of our nodes. Let's fire up our Qt graph. Sure enough, we've got our 4 nodes. So we've got the one that launched that isn't part of the namespace. It's not getting any information. We have our publisher. It looks like the names took correctly. And we are publishing greetings across my topic in this namespace to subscribers 2 and 3. Let's go ahead and press Control-C to stop all of our nodes. We will go back to our code. Now, within my bringup, let's create a new folder called config. Let's say that you create a launch script and you want to be able to choose between different configurations, in other words, different parameters, depending on what kind of application you want to launch. Maybe this is different hardware versions of your robot, or perhaps you want a debug versus production code to run that might turn off or turn on various logging capabilities. You can do that in your launch script if you want to, say, define some variables here, but you can also use YAML configuration files and read those inside of your script. So I'm going to show you how to do that. Inside of our config folder, let's create a new file. We'll call it pub/sub debug, and you can imagine you might have pub/sub production down here as well. I'll show you one. Let's try it with debug, and then let's try it again with a production version. In this YAML format, we're going to have these groupings. The title of each, we'll give it Talkie for our namespace, and we will put our nodes in there. So publisher 1 is that name. Then we will give it ROS parameters. Notice the double underscore here for those parameters. And we will define the parameters message. We'll set that to greetings, timer period 1.0. And let's go ahead and instantiate another publisher. This time we'll have it print out debug mode and print every other second. Let's save this with Control-S. And let's create a new file, and we'll call this pub/sub prod for production. We can define a node in a namespace in a slightly different way. So instead of saying Talkie : and on a new line indented saying publisher 1, we can actually give it its fully qualified name here, where we say /Talkie/publisher 1. That just puts publisher 1 in that Talkie namespace. Same thing. Let's fill out both of our publishers. We will say ROS parameters, message doing stuff, timer period 0.5. And then we will put publisher 2 in that same Talkie namespace, and we will say ROS parameters. We'll just have it print out production mode every other second. Let's save that. Let's create a new launch script. So we can keep this one. You can use this as an example if you're not working with YAML configuration files. We will copy that. We will paste it, and we will rename it to pub/sub config launch. So you can see how to use different configuration files from YAML. Let's close down this terminal for now. Then we need to import several other modules in order to work with those parameters we set in the YAML files. The first is this launch.actions. We will import declare launch argument. Then we will import launch configuration and path join substitution from launch.substitutions. You'll see how we can use those to generate essentially paths in the ROS2 context. Then in that launch ROS package, which is a separate package from launch, we need substitutions and then find package share. Before we create a launch description, we want to get information from those YAML files. And this is a little wonky. We're going to create something like a future. If you remember what futures are, it's kind of a placeholder variable. This config file will be set to this launch configuration object, and we're going to give it the name config file. That will be filled out with information at runtime. So we can't assume it will have information right now. Much like we did with parameters in ROS, when we examined those previously, we can essentially declare a launch argument here. This allows us to pass in different arguments. And what we want to do is pass in a location to a YAML file that this then takes in, reads, and fills out the necessary information to launch the various nodes. So we have this configuration called config file that we've declared. That's going to get filled out dynamically at runtime. Our default value is set to pub/sub debug. So we have to manually override that if we want to use the production version. And we'll give this argument a description. So if the user fails to type it out correctly, they will get a warning that says, hey, you need to fill out the path to the YAML config file. Then we need to dynamically construct the full path to the config file at runtime. We will do this using the built-in path join substitution class that constructs this path for us. Now, I'm sure there's a way you could do this with the built-in Python os.path.join if you really want to. This seems to be the recommended way ROS wants you to do it. I haven't tried it personally, but I'm sure that it would break if you don't do it the ROS way. So here we use it to dynamically find our package somewhere on our system. This should be my bringup, so ROS should be aware of it in the environment when we do that source install setup.bash. We'll tell it to look for the config folder, which should line up to config that we created over here that holds our YAML files. Then we will tell it to find the config file, which is the argument that was passed in at the command line. And so remember, this works as a sort of future. So once the command line function executes, this will get filled out with the parameter that was set here. By default, this is going to be set to pub/sub debug.yaml. But if the user passed something in, it will fill out appropriately here. So this is how you create a command line argument in ROS2 for launch scripts. Now we can fill out that information that we get from the config file. So in publisher 1, we can leave most of this the same. We're going to be launching the same node, but the node name, publisher 1, needs to match the node name found in the YAML configuration file. So publisher 1 should match publisher 1 here, and that's how it knows to fill out the rest of this information. So instead of manually filling out the parameters, we're going to say config path. That's the path to the configuration information, and that automatically gets updated with the ROS parameters we defined here. Next, we're going to copy this, because remember, we're using two publishers now. So we're going to call this publisher 1, and we're going to call this publisher 2. We're going to change that to publisher 2. They should be in the same namespace. Again, that should line up with the namespace defined here. And we should have publisher 1 and publisher 2, and those get their respective parameters filled out. Let's just work with one subscriber. So we're just going to take that subscriber. So now we have two publishers, one subscriber. We're going to change the name to subscriber 1, and that's going to be our only subscriber. The rest of this stays the same. The only thing we need to do here is add an action to fill out our configuration information that we got from those YAML files before we fill out the node information. So all of this gets passed in, hence why we are using futures here, because it's not technically filled out when this is first called. This gets filled out as a future, and the ROS2 backend deals with filling out the actual information from this argument and config file paths. With that, we have our configuration that's set up. Our nodes get added as actions, and we return the LaunchDescription object. Let's save that. Let's go into setup.py. After our example launch, we have a new launch script that we created that is called pub/sub config launch.py. So now we have both that we can call from the command line. And as with anything in ROS2, if we want things to get built and installed, we have to list them out explicitly here. So in this data files field, we will also add the location of our config files. So in share, once things get installed, there should be our package name, so my bringup. There should be a config folder because that gets copied in from our source over here, config. And we should give it the config/pub/sub debug.yaml and pub/sub production.yaml. So that's how we get access to both of those files. And they show up in the path when we call ROS2, so we can just pass those directly in without having to find them somewhere on our system. Make sure that's saved. Let's go to View, Terminal. We're going to go ahead and say call con build, packages select, my bringup, and that should build fairly quickly, hopefully with no errors. Click to get rid of that pop-up. Let's go over to our run desktop. And we're going to say ROS2 launch, my bringup, pub/sub config launch. This is our new launch file. We're going to run that, and you can see it launches our nodes using that debug configuration, because that's the one we set as default. So debug mode keeps printing every other second. If we go to our Qt graph, we can refresh it. We see our two publishers, and we see it printing to my topic to subscriber 1. And that's what we see getting printed out over here. Let's Control-C to stop that. Now, we're going to run the same command, ROS2 launch my bringup pub/sub config launch.py. but we're going to pass in a config file, and ROS2 knows how to handle this, go through that process of assigning the correct parameters as we saw and set up in that launch script. So to do that, we say config file, that's the parameter here, colon equals, because remember that's how we do an assignment within this ROS2 context, and we're going to say pub/sub/prod.yaml. We don't have to give it an absolute path somewhere on our system. ROS2 has already registered that, and it knows where to find that file in the context of our package here. So we'll run that. It fires up the two nodes, and you can see that indeed those parameters were assigned because now it's saying production mode instead. So if we refresh this, the two publishers are the same, the subscribers the same, but the messages are different. Let's Control-C to stop that. I can get out of RQT graph. There is an entire site dedicated to just the launch system or the documentation of the launch system for ROS2. You can go to docs.ros.org/en for English /your distribution, so jazzy/p/launch, and that should take you to this site. In there, there's this top-level page called Architecture of Launch, and you can read all about the launch system. It's a fairly complex beast, and we have only skimmed the surface with how to use the launch system, but hopefully it's enough to get you started creating your own robotics applications. Hopefully, you can see how powerful the launch system is in ROS2. You have a lot of tools and options to fire up multiple nodes as well as switch between configurations as needed. At this point, we've covered all of the basic concepts in ROS2. You should have some familiarity with nodes, topics, services, interfaces, parameters, and launch files. That should be enough for you to start working on your own robot projects. However, we'll take it a step further in the next couple of episodes and talk about the TF2 transform library. This is a foundational piece for building complex robots with lots of moving parts.